Welcome back, friends. I'm now about to do algebraic fractions. This is grade 10 work, but now I want to give this advice to you, all the grade 10s. Make sure that you can factorize. I know you did factorization. Make it a point that given any expression that needs to be factorized, you can be able to do that. Let's go through factorizations, all the forms that are required to factorize. Number one, we are going to give you an expression like that. You see there's an ax plus a, meaning that we have a common factor a. Now, I'm going to factorize by removing the highest common factor, which is a. Then I'm left with, inside the bracket, a into x plus 1. When I multiply these terms, I will get that. Now, I have fully factorized that expression. Number two, remember you did factorization that involves the difference of two squares. Make it a point that you are still able to factorize the difference of two squares. That must be a perfect square. That must be a negative, not a plus. And that must also be a perfect square. Now, remember when you do that, it is just the same as taking the square root of that which is x, you put it here and there. You take the square root of that which is 3, you put it in this bracket and that bracket. You give us different signs, plus or a minus or a plus, it makes no difference. You have factorized the difference of two squares. That is important. Number 3, if I give you x squared plus x minus a 4, that is now a quadratic trinomial. This was a quadratic binomial. Alright, given the quadratic expression x squared plus x minus 2, be able also to factorize it, and its factors would be factors of x squared, x and x. Factors of 2 would be 2 and 1. Because we want a plus there, the bigger number must be plus. We want to subtract, that must be minus. We have factorized that. Now, the last one, which is the fourth one here, not last one in terms of factorization, would be x cubed plus 64. Be also make sure that you can factorize that. Let us not make it too heavy. Let's make it 27. Alright, when it is 27, it is a bit fine now. Factorizing this, remember you open a small bracket, you open a big bracket. It would be factors of x cubed, it would be x and x squared. Factors of 27, remember here we don't want a perfect square. The perfect square must be there, it would be 3. Then there it would be 9. Because it's a positive here, it stays positive there, it stays positive, so that when you multiply these, you get a positive 27. Now, next thing, you multiply this one by this one, it gives you 3x. a plus 3x. Now you change it there, you make it a minus 3x. Now, folks, you have factorized the sum of two cubes. Let's go through this again. Make it a point that you can factorize an expression where you just remove the highest common factor. Number two, you can factorize the difference of two squares. Number three, you can factorize a quadratic expression. Number four, you can factorize sum or difference of two cubes. Now, if you can do all those, I'm telling you now, you won't have any problem here. Let's go through this one now. It says simplify. What I normally do is, I go through each expression individually, checking whether it can be factorized or not. Now, I'm going to go through that one. I can see a minus and a minus. I'm seeing a 4, I'm seeing an 8 there. And I don't have a perfect square here and there. That means I cannot do that. Rather, I can factorize by removing the highest common factor, and the highest common factor in this case is a negative 4. Now I'm left with x plus a 2. You see now, I have used that here. Second one, I go through that one. It is x squared minus 4. That means I'm dealing with the difference of two squares. Let's factorize that. It would be x, it would be x. It would be 2 and 2 there. We just go x plus, minus and a plus. Bring down that plus sign. Now, we go to this one. Let's look at that. You have x squared there, plus a 2x, you have 4. How can you factorize 4 such that you get 2 from 4? It looks impossible. Now, just leave it as it is, because you can see that at this point, you cannot factorize that. Remember, the factors of this one and this one must work together to give you the factors of that one. Now, in this case, what are we going to do? Let's factorize this one. My friends, if there's one quadratic trinomial that cannot be factorized, never worry. Just look for the difference or the sum of two cubes. You must know that this one will help you with that one. Let's see what I mean. I'm factorizing this. It would be x. It would be x squared there. Then, okay, let me do this first so that I have enough space. Factors of x cubed, x, and x squared. That's good. Factors of 8. 2, it must be a prime there. 4, it must be a perfect square that side. Now, because this is negative, this must be negative. When I multiply this and that, I want to get a negative. It means that this one must be a plus. Now, I multiply these two, I get a minus 2x. I want the middle term there. I get a minus 2x. I change its sign. It becomes a plus 2x. Now, I've got the middle term there. We bring down the negative sign. Can you see that this expression is exactly the same as that. Now, let's look at that one. What I'm seeing there, I'm seeing a quadratic expression that can be beautifully factorized. It would be x and x. Where am I now? I'm here. It would be, because I want 1 there, it must be 3 and 2. The 1 is negative. I must make that positive. Now, look at this one. 6 minus 2x. That means we are going back to that again. How am I going to factorize it? By removing the highest common factor, which in this case I'm going to say first, it is 2. Now I'm left with 3. 2 times 3 is 6. 2 times minus x is a minus 2x. Now, folks, I have factorized everything. What is the next step? Because I'm now multiplying and dividing and multiplying, I look for those that are the same and cancel them. Can you see that I've got minus 4 times x plus 2, x minus 2 times x plus 2? That means I'm going to cancel this bracket and that bracket. I'm left with minus 4 divided by x minus 2. Nice one. Let's move on. Let's bring down the plus sign. Now, let's put that inside the bracket. Can you see that this expression is exactly the same as that? Now, I cancel the whole expression by that because I'm dividing. I am left with a 1 there divided by x minus 2. I bring down that minus sign. Whoa, be careful here now. Be careful here. Can you see that I've got x minus 3 times x plus 2 divided by 2 times 3 minus x. These two brackets are not the same, folks. They are not. That is x minus 3, which is not the same as 3 minus x. Now, if I want to cancel that, I must fix one of them so that it becomes equal to the other one. Now, look at this. If I can remove the minus sign there as a common factor, it is going to be minus, that is now minus. Minus times a minus is a positive. Minus 2 times minus 3 is a positive 6. Now, in that one, it would become a plus because I'm dividing by minus. Now, it would be minus 2 times plus x, which is minus 2x. Now, look at this, folks. Minus 3 plus x is exactly the same as x minus 3. Therefore, I can cancel that and cancel that. Now, look at what is happening here. I've got a negative, I've got a negative there. I must multiply them, I get a positive. I am now left with x plus 2 divided by 2. Remember, that negative multiplied that and we got a positive. Now, from there, I can see that I am adding fractions which have been simplified now, that are having denominators. The two are having denominators which are the same, but this one does not have the same denominator. I can start with these two. Remember, if the denominators are the same, you add the numerators and take the common denominator. Minus 4 plus a 1 is a minus 3. I take the common denominator there, which is my beautiful x minus 2. I bring down that one. I have x plus 2 divided by 2. Okay, let's put that division line there. Now, I'm going to draw a division line there. Why? Because now, the denominators are not the same. I want to have the lowest common multiple. How do I get it? I multiply this by that. It becomes 2 multiplied by x minus 2. Beautiful. Now, after that, I divide the lowest common multiple by the denominator there. It would be 2 multiplied by x minus 2 divided by x minus 2, which is 2. I multiply 2 by minus 3, which is a minus 6. I bring down the plus sign. Then I again do what I did there in that one. 2 into x minus 2 divided by 2, which is x minus 2. I multiply x minus 2 by x plus 2. X minus 2 multiplied by x plus 2. Then I simplify the numerator there. It will be minus 6. Can you see that here? We have 2 brackets which are the same and the signs are different. Let's go back there. 2 brackets which are the same with different signs. It means I can multiply this and that. Now, I will be having plus x squared minus 4 divided by 2 into x minus 2. Now, let's take it right up there so that we don't confuse ourselves. We would put that blue line there saying this work and this work are not friends, though they are cousins. Now, let's see here. I've got x squared. I'm going to put that x squared. I'm adding like terms. Minus 6 minus 4 is a minus 10 divided by 2 into x minus 2. Now, folks, we have simplified this algebraic fraction. Let me just go through it quickly again. Folks, make it a point that you can factorize any given expression if it must be factorized. Now, I normally see some of our friends trying to factorize that. If you think that factors are factors of an expression, quickly multiply them. If they don't give you that expression, it means those factors are not factors of this expression. Now, if you check, you will see that here you can't factorize, but this is going to help you with that. Folks, after factorizing, cancel the same. We did that. After that, you will have fractions which are now in a simple form. If the denominators are not the same, look for the lowest common multiple. How do you get it? You multiply those denominators that are not the same. Like in this case, it was this one multiplied by this one. It gave us that one. Remember, this is the same as that. I just quickly added these ones and I got that. But this denominator was not the same as that. I multiplied the two denominators to get the lowest common multiple. Thereafter, I divide the lowest common multiple by each one of them, multiply the numerator by the quotient that I get when I divide this and that. Then, after that, I simplify what I got, add the like terms. Then, at that particular point, there's absolutely nothing that you can do, even though other people say, why don't you remove the brackets there? I always say, it is not necessary. Folks, like our channel, leave a comment, invite your friends, don't get help alone. Make it a point that everyone is succeeding with you. Thank you very much.